Hello, good day to everyone. It is my pleasure and honor and great delight to introduce our guest who is very well known to you, specifically those of you who came to the fabulous 2017 World Congress Neurology in Kyoto. Our guest today was a key, the mastermind behind the Kyoto Congress. This is Professor Ryosuke Takahashi. He is a senior professor of neurology and chair of Kyoto Medical School Department of Neurology. He has a long CV, which I'm not going to read. The Ryosuke, very good after evening to you. Thank you so much for making your time today for World Federation Neurology World Brain Day team and social media team. I know that you had a very long day today on a full day webinar, but still you agreed to chat to us. Today discussion is going to be a little bit different. I want you to go back to your school days. So take us through your high school days and tell us, why did you become interested in medicine?
Oh, thank you very much. Thank you very much for your kind invitation to this interview. And it's my pleasure to talk about my high school life. So in response to your question. When I was a high school student, my favorite thing is reading books. So I read a lot of books, novels, stories, and what, at that time I wanted to be a novelist or some man of literature, not a medical doctor.
Right.
Yeah, but as I read books, I think the science is one of the possibility that I should pursue in the future, because literature is sometimes not objective. You know, it's hard to evaluate objectively, and it's a fun. But if make a novel writing things as a profession, it may be a torture for me, not a fun. So I decided to do some research or science in the future, and when I look around, I think the area of medicine is very fascinating. You have a lot of choice. You can become a researcher, or you can become a basic researcher. You can become a clinical researcher, or you can become clinician too. So I was not I wasn't sure I'm what is my the best choice uh, at my high school days. So I chose medicine as my future future direction, because we have a lot. I think I have a lot of choice in the field, and also the field is very fascinating because it's very medicine is very important for human beings.
Absolutely. And so you went to Kyoto Medical School, then you pursue a career in neurology as you graduated from Kyoto Medical School. What inspired you to be interested in human brain and neurology?
That's a very important question. When I was a second grade of the medical school, I read a book on the brain science, which was written by Masao Ito, who unfortunately passed away 3 years ago. But he's a very world famous neuroscientist who found that Purkinje cells is inhibitory neurons, and also he found a famous phenomenon, long-term depression in cerebellum. And his book for young scientists, young people, was also very comprehensible to even a university student or even to a high school student. And he write about the fascination of neuroscience, because he contributed very much to elucidation of the neural circuits in the cerebellum, which is very important for the control of the motor function. So So I was very much fascinated by first by basic neuroscience at that
Mhm.
time, and when I became a fifth grade of medical school, fifth grade student of the medical school, I attended a lecture of neurology,
Mhm.
and I learned a lot about very intractable neurological diseases, including ALS, amyotrophic lateral sclerosis,
Mhm.
Parkinson's disease,
Mhm.
and other multiple system atrophy, so such a neurodegenerative diseases.
Mhm.
So I I thought that people suffering from such neurodegenerative disease should be saved in somehow saved in the future.
Mhm.
But nothing. I was when I was a university student. It was almost it was 40 years ago.
Mhm.
Nothing was known about neurodegeneration.
Mhm.
So it was so in some sense it is difficult area because you have no clue for elucidation of such difficult diseases. But fortunately, at that time, just when the time at the timing when I graduated from the medical school, the new genetics has developed very rapidly,
Mhm.
molecular genetics. So and molecular genetic approaches seems to be very powerful to elucidate the cause of such a such enigmatic neurodegenerative diseases. So I am very looking at the developing uh, the power of neurogenetics. I decided to do research on neurodegeneration.
Mhm.
When I graduated from the medical school.
I believe your first gig as a career was in pure science, in other words, laboratory research, and you spend first part of your career, almost 6 years, as a neuroscientist, almost totally. Am I correct? And you were basically trying to answer the question why neurons die.
Yes, yes. Thank you very much. But actually, I as I said, I decided to do pure basic science research on neurodegeneration
Mhm.
ultimately. But first, I thought it's necessary to learn about the disease
Mhm.
by looking at human patients,
Mhm.
seeing human patients.
Mhm.
So I first chose to become a clinician,
Mhm.
a neurologist
Mhm.
first.
Mhm.
So I started my career as a neurologist,
Mhm.
and seeing many patients with neurological diseases. And it was so the first 6 years after my graduation, I dedicated to to clinical work as a neurologist.
Right, right. So first trained in neurology, completed the residency, and became a neurologist.
Uh,
Then,
yeah. Then yeah, and then I chose. Then I turned to converted to basic scientist, which
how
was
did this was perceived by your family? Wasn't your wife unhappy that you become a neurologist? So she would have been waiting for you to do clinical work and have a happy family life. And here, instead of that, you would come home and tell her that, hang on a second, I want to now go to the lab to learn how to become a neuroscientist. How did she take this when you came
oh
back and told this to her? I'm sure you would have had a child or two by this time also.
oh thank you. It's excellent question. But you know, in Japan, at least in Japan, the salary for clinician and salary for basic scientists is not so different.
Ah, right,
So
right, right,
so so economically, it's no problem.
right,
And
right,
also, I was a long time worker. I
right,
not not necessarily hard worker. So
right,
I stayed long in hospital.
right,
Eh, And if I become a basic scientist, that only changes I stay long in the institute, not
right, right, right.
hospital. So
So,
the
so
life
for her, no
doesn't change.
difference,
not no difference.
no difference. So she didn't
No.
notice any difference at all.
Right, right.
And the tell us about the experience. So when you when you finished clinical training and when you went back to the laboratory, did you feel that you made the wrong choice, and did you feel like coming back to patients, or did you start enjoying the laboratory work just as you enjoyed patients?
Yeah, I actually I like to see patients, so it's also give me a pleasure to tweet to listen to the story of patients and
Mhm.
give some effective medication. But uh, I I very much enjoyed laboratory work
Mhm.
because um, you can you can you, you can answer, you can address the question you want to solve, which and these questions are arises in my clinical works. So when I see the patients, many research questions um, emerges every day. But I have when I do clinical works, I have no time to address these questions. But I when I go to the laboratory, I can ask these very important questions regarding neurodegeneration. The most important question is, as you said, why neurons die in neurodegenerative diseases.
I'm going to spend some time on this question. I can now see that how visionary you were. You first study clinical material, so you got a good grasp of how people are becoming sick. Then you probably realize that by the time you see patients with multiple system atrophy or Parkinson's disease, the bus has gone. So they are now in the phase of neurodegeneration. You wanted to get them way before that to see whether you can fix that. So your first question would have to be why these neurons die. So if you answer why neurons die, then you could go and try and attempt how can I stop them from dying. I'm just
Right,
I'm
right.
just I'm just hypothesizing your thinking at that time. So it is no surprise then the Professor Takahashi spent almost 15, 16 years in that laboratory, initially as a scientist, probably junior, then becoming a senior scientist, then becoming the laboratory head during
Right.
the latter years. So take us through I think you were very prolific from this lab. I think your publication number is almost close to 500 now, certainly 400 plus. You publish some seminal papers in Nature Genetics. The I didn't read them recently, so I can't question on them, fortunately for you. But they were classic papers, and some of those papers were cited well over 1,000 times. That basically tells the audience how impactful those papers are. So, give us a summary of what you learned during those 16 years trying to answer the question why neurons die in neurodegenerative disorders.
Oh, thank you very much. So, uh, as I said, when I started the research, nothing is known about the cell death which occurs in neurodegenerative diseases. But at that time, there's some fascinating hypothesis was produced about the neurodegeneration. First one is uh, maybe neurodegeneration should be caused by the deficiency of survival factors for specific neurons. It can explain many causes of neurodegenerative diseases. For example, in Alzheimer's disease, cortical neurons or hippocampal neurons selectively die. In ALS, motor neurons are selective die. And Parkinson's disease, dopaminergic neurons are selectively killed. So, and on the other hand, uh, there are uh, there are several neurotrophic factors which are already cloned at that time, and most of them are specifically affective to some specific neurons. So, um, uh, so NGF, the prototype of neurotrophic factor, a new nerve growth factor, specifically saves the life of sympathetic and sensory neurons, not effective for motor neurons.
Mhm.
So such selective nature of neurotrophic factors can explain the cause of neurodegenerative diseases. Probably the deficiency of such neurotoxic factors selectively effective for some specific neurons can explain the causes of uh, these diseases. So I first tried to clone a new neurotoxic factor, which is essential for some specific neural system. For example, at that time, there's no motor neuron factors are known. So I tried to clone such factor, and fortunately, before I cloned the new factor, a German scientist identified a new motor neuron factor.
Mhm.
So in mouse. So
Mhm.
I cloned the motor neuron factor, that motor neuron factor. The name was ciliary neurotrophic factor (CNTF)
Mhm.
in human,
Mhm.
and I cloned the human CNTF. Very fortunately enough, uh, it was mutated.
Right.
I I took human sample, which I took a sample of nerve from ALS patients who died because
Mhm.
of disease, and I cloned the factor, and it was mutated. So
Mhm.
I was excited at that time because this deficiency or mutation of neurotoxic factor may cause ALS.
Mhm.
So that's what I thought at that time. So, but to make a long story short, it was not.
Mhm.
It was mutated, but it was not the cause of ALS. But because the mutation, it is the first identified mutation in the human neurotrophic factor. I could publish that results in Nature Genetics as
Mhm.
my thesis paper.
Mhm.
So that was the initial success of my research life.
But that story is fascinating. So you basically, what you have told the audience is that the reason that different neurodegenerative disorders have selective death in selective components of the brain, say for an example, dopaminergic neuron in Parkinson's disease, hippocampus and temporal regions in Alzheimer's disease, and motor neurons in amyotrophic lateral sclerosis or Lou Gehrig disease or motor neuron disease
Right.
was the example that you shown. And then what you told us is that even by this time, various neurotrophic growth factors were identified that are specific for some of those things. And your hypothesis was that perhaps the reason that these disorders lose these important areas is perhaps some of these growth factors are missing or mutated or changed. Hence, there's not enough nutrition for those tissues to be viable. And then you manage to clone one such factor, which you named as CNTF, that you managed to publish. And for some time, you felt that you found the cause behind amyotrophic lateral sclerosis, but later it found to be not the case. Has the science progressed further since then, Ryosuke, in your lab in this area?
Uh, not much.
Right, right.
CNTF, yeah, CNTF about CNTF, yeah. But yeah, CNTF is still a very interesting factor, and I found a mutation of CNTF in humans, but they are perfectly okay. They're healthy, but
Mm-hmm,
still they're lacking in CNTF. So what CNTF doing is still a mystery.
mm-hmm,
CNTF in vitro, in cultural cells, CNTF works very robustly to save the lives of neurons. It
mm-hmm,
has a very powerful effect on the survival of motor neurons and other type of neurons. But in culture, but and also the experimental animals. But when the factor is lost, the factor is gone, no problem for
mm-hmm.
at least for humans. So
Is it possible that there is something else that is missing or mutated or dysfunctional in those parts or those neuronal component in these disorders to cause them to die, rather than the other theory of just precipitation of misfolded protein causing these diseases.
Yeah, actually, as you said, the deficiency of neurotrophic factor is a fascinating hypothesis for cause of neurodegeneration. But 40 years, almost just 90, 20, 30, almost 30 years has passed since my publication of mutation of CNTF. No example of neurodegeneration which is caused by deficiency of neurotrophic factor is found. So I think the initial hypothesis was wrong, at least for the time being. And as you said, uh, instead of such theory, misfolded protein hypothesis emerges as a promising new hypothesis for neurogener for the cause of neurodegeneration. And I think many people, including myself, believe that is a very important feature of neuronal death in neurodegenerative diseases in general.
I was also quite fascinated with what we have seen in COVID-19 last year. As you know, we had a sort of a hard hit exposure in Melbourne. In fact, my hospital looked after the largest number of COVID-19 patients, and I studied them really carefully. I didn't have access to a lab, but I basically looked at how their peripheral blood counts and other things were circulating, and I end up defining a new index also that I publish as a letter in the Journal of Clinical Neurological Sciences as one of the patients with long COVID, which I define as post-COVID-19 neurological syndrome. He wasn't Parkinsonian. He isn't Parkinsonian just as yet. I still follow him up. He was with us for about 4 months, but it was quite fascinating to see how his peripheral blood counts were behaving on a daily basis. My junior team thought that I have gone mad as I was plotting these cell counts on a daily basis on an Excel spreadsheet on a sort of side of the ward round. And that helped me to define this particular index and then pointing out to the world that how various neurological symptoms were correlating with how his innate and adaptive immune system is responding to this post-viral issue. Obviously, it is early days. My next question is on the basis of that. Based on that, you must have read the very small number of cases of Parkinson's disease that emerge post-COVID-19. Very small numbers, only handful of cases. Do you think that the post-COVID-19 world might give us an indication now that science is more advanced compared to encephalitis lethargica days, for us to exactly understand what's happening in these patients? I'll let you answer that question first, then I got another question to ask from you also. I know that this is all hypothetical and none of us know the exact answer to this question, but this is for the intellectual curiosity.
Yeah, thank you. So COVID-19 gives fortunately Japan is not hit very severely by COVID-19 compared with Europe or the United States. I think Australia is also escaped from the really severe damage. Similarly to Japan. But as far as I see the new regarding the neurological symptoms, regarding long COVID, as you said, I'm most interested in the hyposmia caused by COVID-19. Yeah, it attacks your olfactory system. So the waves get into your body through the olfactory epithelium and goes up to the olfactory bulb. Sometimes it severely damage olfactory bulb, and you will lose the olfactory function forever, unfortunately. But
up to 60% sometimes.
Yeah, up to 60. Yeah. Right, you are right. more than half of the people may partially or completely lose the olfactory function. But the olfactory bulb is also very important for Parkinson's disease. Um, now, many people believe that alpha-synuclein, misfolded alpha-synuclein or oligomer of alpha-synuclein may cause the cell death in Parkinson's disease. And and what is worse is alpha-synuclein oligomer or misfolded alpha-synuclein propagate from neuron to neuron and spread spread to the wide area of the brain. That is a very um, it's a
Plausible hypothesis. Plausible
yeah,
hypothesis.
plausible hypothesis. So and also there are many some people claim that viral infection in the long run may cause some neurodegenerative diseases. So in Alzheimer's or even in Parkinson's. So I what my curiosity my what I want to see is what happened to the people who was affected with COVID-19, especially uh, whose olfactory bulb is affected, um, develop Parkinson's disease in the long run. So that may cause it's a just really scientific interest, but it could be. I think it one of the possibility, and also long as you said, long COVID is may become a very serious problem in the future uh, in terms of psychiatric diseases. Chronic fatigue syndrome is a really enigmatic disease, which some people think it's a psychiatric disease, but some people believe it's a neurological disease is caused by organic damage to the brain. So, but there's some epidemiological evidence that chronic fatigue syndrome is caused, it happens, is prevalent after a viral infection. So COVID-19 is a really a pandemic give rise to many patients, and as a result of that, I'm afraid many people suffer from chronic fatigue syndrome, and because of that, as a result of this, yeah, that's my the two thoughts I have now for COVID.
I think that gives us nice segue to move on to the next topic, which is the theme of this interview, World Brain Day. World Brain Day, as you are well aware, was started in 2014. World Brain Day is a major activity of World Federation Neurology. Basically, what we do is the World Brain Day Committee usually partner with a partner organization. Last year, we partnered with Movement Disorders and Parkinson's Disease Society, year before International Headache Society, year before World Stroke Organization, before the International League Against Epilepsy, so on and so forth. So this year, our partner is Multiple Sclerosis International Federation. You are well aware that both multiple sclerosis and similar disorder, neuromyelitis optica and neuromyelitis optica spectrum disorders are not uncommon in Asia, Oceania region, including Japan. Right. So what we normally do is we create what is known as World Brain Day Toolkit. We deposit them on our World Brain Day 2021 page. This video is also part of the material that we prepare. This would also be deposited in our YouTube channel along that path so that people can come and look at what we talked about and then use some of the things that we mention here for the advocacy program. And then we also deposit some slide decks about sort of a series of social media posts with images. They're all in English, including some press releases, but they can be translated to Japanese, Chinese, Sinhalese, Tamil, Italian, Spanish, Russian, Chinese, any one of those languages as people feel as choosing. So the idea is the different neurology societies use this material to promote brain health in their region, in their hospital, in their country. So you might do radio shows, TV shows, Twitter posts, Facebook posts, webinars, so on and so forth. We also have a couple of webinars. Last year, we had the main webinar first webinar on World Brain Day. Then at the Movement Disorders Virtual Congress, we had another live webinar with MDS President joining also, and some question and answer session. Similarly, this year, during the World Congress, we would have the second webinar, first webinar on 22nd of July, and third webinar at ECTRIMS meeting, which will be virtual as you are aware. So we would encourage Japanese colleagues and Japanese Neurology Society, which you were the president a few years back, to visit our website and download the toolkit. That's one way of participating. Another way that they can participate is anyone who is keen to support us, they can get their mobile phone out and then do a short video saying that I am so and so, and I support World Brain Day, and I promote brain health. Some sort of a 30-second video clip. They can post it on their own social media posts, and they're more than welcome to send it to us at WBD 2021 at wfneurology.org, which is available through website. So as a clinician scientist and the academic chair of neurology and a leader in neurology, both movement disorders and neurology, how excited are you to hear that this sort of a program is happening and it is slowly spreading all over the world? How do you see this and benefits of this as an academic neurologist?
Thank you. As you said, brain is the most important organ in the human body. So everyone probably recognize it. But the medicine about brain is not so popular among people, and people are not so familiar with what we neurologists, the brain doctors, are doing. So we are protecting the most awful. We should be afraid of the brain, the damage to the brain health in the future of yourself. Because if you become old, you may get Alzheimer's disease, you may get CVD, you may get Parkinson's disease. All of these neurological diseases are major threats to everyone in the world. And we neurologists are seeing the patient, not only seeing the patient, but neurologists together with neuroscientists try to overcome these diseases. And actually, some neurodegenerative diseases, some neurodegenerative diseases are very well treated by new medications. For example, Parkinson's disease patients lives maybe 70 lives up to 70, 80, or even 90 years old if they are treated properly with the current cutting edge therapeutics. And also new therapies about Alzheimer's disease has emerged. As you know, antibody therapy was approved by FDA, and many other new therapies or new gene therapies are developed for really intractable diseases. So I think the World Brain Day movement is really important for the people to be aware of the importance of neurology and the brain science and neuroscience. So I'm really impressed by your dedication to this activity. And Japanese Neurological Society also should contribute to the brain awareness as you have proposed.
Absolutely, I totally agree. And the current pandemic and the threats that we face as one world or humans is a timely reminder that everything that we do, from our behavior, our way of dealing with this, is primarily controlled by brain. So the brain health, as you very correctly pointed out, compared to our medical student days, we have some excellent therapeutics at the moment. So that's one thing that we need to be aware of them. And also, we are now making some headway into why we behave in certain ways, the reasons behind our human behavior, mindfulness, consciousness, kindness, compassion. Those soft targets are being investigated and studied also. Basically, our brains basically decide who we are and why we do certain things in certain way. So it is of paramount importance for us to talk about it and raise awareness and know that the brain is indeed important. And it is probably worth reminding that the one of our former president, Vladimir Hachinsky, Professor Hachinsky, recently published a little correspondence in Lancet Neurology, which I used to write an editorial on World Brain Day in multiple sclerosis, which will be published in a week or 2 weeks' time. He goes on to say that when you look at the definition of health by World Health Organization in 1948, as you are aware, is complete social, mental, and social well-being, not mere not having the disease or infirmity. That was the sort of a definition of World Health Organization health that we both caring for. But his argument is that he wanted this to be the aligned with the new definition of brain health as we get older, protecting brain health and then exercising our brains to maintain the real value of health. In another word, there's no health without brain health. If your
Right.
brain health is non-healthy, there can't be any health because there is no social or psychological or the physical well-being when your brain is not working. That's your main central processing unit of the body. So you're absolutely right. So my last question is: we talked a lot. The you have an illustrious career, the over almost 4 decades now, from your student days to today. You move back and forth between basic science because you wanted to know the disease mechanisms, and now you chair a department. It's a different generation that we are training now. What is your advice to younger generation? What are your take-home messages to youngsters wherever they are?
Okay, thank you. So time has passed, and probably there should be some generation gap between myself and the young people. But I'd like to give you a message which I borrow from very famous scientist, Joe Goldstein. Have you ever heard of the name of
No,
Joe
no,
Goldstein?
no.
He's a Nobel laureate of medicine who discovers the mechanism of cholesterol regulation.
Mm-hmm.
So in his a very interesting article, um, he 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 summarized the what is a physician scientist in a formula. He his formula is clinical stimulus multiplies basic science training gives rise to uh, fundamental discovery.
Mm-hmm.
So if you have a clinical stimulus and you address the question after taking a basic science question, a basic science training, you may um, get fundamental discovery. There's too many examples in the history of science who made a really fantastic discovery as a to digging into the clinical question by basic science. So his article was written 40 years ago, just 40 years ago, but still, so clinical stimulus plus basic science training leads to fundamental discovery holds true. So I think my message to young scientists, young people is, if you become a physician scientist, it is also a very nice, wonderful life. So please think about it too.
Absolutely. I think that's a very key, important message that you said. While randomized double-blind control trials and all the therapeutic advances are very important, one of the key things that should be in our foundation is keep asking the basic questions and asking the questions behind mechanisms behind disease. Just like you were trying to answer the question, why do neurons die in
Right.
neurodegeneration? Because without answering that question, it is very hard for you to answer that question, because your answer has to be at the level of disease mechanism. It's very similar to COVID-19, isn't it? If someone is going to develop Parkinson's disease or long COVID or post-COVID-19 neurological syndrome, you must know what drives that if you were to have any chance of fixing it in the first place. And I'm a little bit ashamed to not to know this great gentleman that you mentioned. I will search him just after this interview, and I'll try and dig this paper. And
I'll send you the article
and
after this.
but he was spot on. I think that's probably why we, even at the medical school, we learn these basics in the first place, isn't it? In the context of physiology, anatomy, biochemistry, biochemical pathways. And when you start seeing patients, it all starts to make sense. And I got a lot more questions to ask from you, but we already spent almost an hour. I know that you had a very long day, and I think I should come back to you for another intellectually stimulating chat some other time once we get this World Brain Day activities completed in the coming months. My sincere gratitude to spend time with us and share your wisdom with us. We wish you and your family and your colleagues all the very best, and stay safe and well. And we look forward to seeing you face to face once this pandemic is over one day.
Yeah.
Thank you so much. All the very best.
Yeah, thank you very much. I really enjoyed this chat with you. Thank you.
Likewise.